Hi friends, today we are going to discuss some numerical problems from the chapter Atom. Okay, so now we are going to discuss a numerical problem from the chapter Atom. So this is the question. So what is the shortest wavelength present in Parsons series? So what is the shortest wavelength present in Parsons series? Given data is R is equal to 10 raised to 7 meter raised to minus 1. Here R is called Rydberg constant. R is called a Rydberg constant. Okay, so before going to solve this problem, we need to study what are the spectral series in hydrogen atom. So what are the spectral series in hydrogen atom? So one of the spectral series in hydrogen atom is Lyman series. First one is Lyman series. Okay, and second one is Balmer series. This Lyman series belongs to UV region. The Lyman series belongs to which radiation? UV radiation, and visible belongs to Balmer's series. Visible region belongs to the Balmer series. After that, the first we got Lyman, then Balmer, then next one is Parsons series. It belongs to IR region. The next one is Brackett series. Series also belongs to IR region, and next one is Fun series. This also belongs to IR region. So Parsons series, Brackett series, and Fun series belongs to IR region, and these two belongs to far IR region. Parsons is IR region, Lyman series visible UV region, Lyman series belongs to UV region, Balmer series belongs to visible region. Okay, so next we are going to discuss how we are getting the wavelength correspond to each region. We are going to discuss how we are getting the wavelength corresponding to each region. So we are using an empirical formula for finding the wavelength corresponding to each series. So this empirical formula, 1 by lambda is equal to R into 1 by N1 square minus 1 by N2 square. So this is the empirical formula we are using for finding the wavelength corresponding to each spectral series. So lambda is the wavelength, R is called Rydberg constant. The actual value of Rydberg constant is 1.09 10 raised to 7 meter raised to minus 1. This is the actual value of Rydberg constant. And N1 is the lowest energy level, the base level, and N2 is the higher energy level. Okay, clear? In the case of hydrogen atom, first series is Lyman series. For Lyman series, the wavelength is given by 1 by lambda is equal to R into 1 by 1 square minus 1 by N2 square. So base level is the first energy level, and here N2 is equal to 2, 3, 4, etc. That's for Lyman series. For Balmer series, the 1 by lambda is equal to R into 2 square N2 square. Here N2 is equal to 3, 4, 5, etc. This for Balmer series. Okay. Next for Parsons series. For Parsons series, this basic level is 3 square and N2 is equal to 4, 5, 6, etc. This for Paschen series. Next one is bracket series. For bracket series, the basic level is fourth level, that is 4 square minus n2 square. Here n2 is equal to 5, 6, 7, etc. Okay, so next level is fun series. For fun series, the basic level is 5, fifth one, this is 5 square, and n2 is equal to 6, 7, 8, etc. So these are the equation used for finding the wavelength corresponding to the each region. Okay, so general equation is 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. n1 is a base level and n2 is a higher energy level. Okay, so here the question is, what is the shortest wavelength present in a Paschen series? That we need to find out. Okay, so the given data is only Rydberg constant is given, r is equal to 10 raised to 7 meter raised to minus 1 is given. And it is Paschen series, the base level of Paschen series is n1 is 3. n1 is 3. Okay, so we need to get the shortest wavelength. For getting the shortest wavelength, they need to make a transition from infinity to that level. For getting the shortest wavelength, there will be transition from infinite to that level. Okay, so that means here n2 is equal to infinity, then only we get the shortest wavelength. For getting the longest wavelength, that they should be transition from the next to that level. Next to that level. Okay, for getting the longest wavelength for Paschen series, here n2 should be 4. For getting the longest wavelength, n2 should be 4. But here we need to find out the shortest wavelength. So we can use the empirical formula. What is the empirical formula? 1 by lambda is equal to r into 1 by 3 square minus 1 by n2 square. This is for Paschen series. For getting the shortest wavelength, what is the value of n2? n2 is infinity. So what we can write here? 1 by lambda is equal to r into r value is given. We can substitute the value of r. R value 10 raised to 7 into 1 by 9 minus 1 by infinity square. So infinity square, this value is 0. So what will be the remaining one? So what we can write here? So 1 by lambda is equal to 10 raised to 7 by 9. 1 by lambda is equal to 10 raised to 7 by 9. So we can write, therefore lambda is equal to 9 by 10 raised to 7, that is equal to 9 to 10 raised to minus 7 meter. So this is the shortest wavelength corresponding to the Paschen series. For getting the shortest wavelength from a spectral series, you should make a transition from infinity to that level. For getting shortest wavelength for Lyman series, there should be transition from infinity to n is equal to 1. For Balmer series, it should be transition from infinity to n is equal to 2. For Paschen series, from infinity to 3. For getting bracket series, infinity to 4. For getting fun series, infinity to 5. Then we get the shortest wavelength corresponding to each series. Clear?